Have you ever looked at a city street and realized that you are standing on top of a massive, living machine? Most of us walk through downtown areas seeing only concrete, glass, and steel. But beneath your feet is a hidden world of critical infrastructure that is constantly breathing, pulsing, and thinking. If you could peel back the pavement like a rug, you would see a chaotic but organized web of color-coded pipes and wires. In the United States, there is a universal color code for what lies beneath. Blue pipes carry fresh water, yellow pipes carry combustible gas, and red conduits house high-voltage electricity. This hidden map ensures that a construction worker in California and a repairman in New York both speak the same visual language before they ever start digging. This underground world is the reason a city of millions can function without collapsing. It is a silent marvel of engineering that we only notice when it breaks. But as we move into the future, these dumb pipes are being replaced by smart sensors that can feel a leak before it even happens. Some roads feel fast, while others feel slow. Even if the speed limit sign says the exact same thing, this is not an accident. Urban planners and civil engineers use a concept called self-explaining roads to manipulate your behavior without you even realizing it. They use visual cues to tell your brain how to drive, rather than just relying on your eyes to read a sign. For example, think about a wide, multi-lane highway. The lanes are broad, the shoulders are clear, and there are no trees near the edge of the asphalt. In this environment, your brain perceives a low level of risk. Because you feel safe, you naturally press harder on the gas pedal. This is why it feels so difficult to drive 40 miles per hour on an empty freeway. The road geometry is literally screaming at you to go faster. Now, compare that to a narrow city street lined with parked cars, tall trees, and curb extensions. These elements create what designers call side friction. By placing objects closer to your peripheral vision, the engineers make you feel like you are moving faster than you actually are. This creates a sense of psychological discomfort, which causes you to naturally lift your foot off the accelerator. Engineers even use optical speed bars, those painted white lines that get closer together as you approach a sharp curve. As the lines pass under your tires more frequently, your brain panics and thinks you are accelerating out of control, forcing you to brake. It is a brilliant, invisible way to save lives using nothing but human instinct. Have you ever noticed a worn, muddy trail cutting across a perfectly manicured lawn, right next to a paved concrete sidewalk? These are what urban planners call desire paths, and they are the physical evidence of a rebellion against design. While an architect might draw a 90-degree angle on a blueprint because it looks clean and orderly, the human brain is hardwired for efficiency and least effort. We naturally want to take the shortest route between point A and point B. Desire paths are fascinating because they represent a democratic design process. Instead of a single designer deciding where people should walk, the collective footprints of thousands of people show where they actually walk. In some of the most famous campus planning success stories, universities like the University of Oregon or Ohio State famously chose not to build any sidewalks at first. They simply planted grass, waited for the students to wear down natural dirt trails, and then paved over the paths that the people had already chosen. This concept isn't just for parks. It has moved into the digital world, too. Software developers watch how you use an app, where you click and what buttons you ignore, and then they redesign the interface to match your digital desire paths. It turns out that the most successful designs in the world are not the ones that force us to follow a plan, but the ones that observe our natural instincts and build a world around them. Have you ever walked past a townhouse or a storefront in a busy city and noticed that something felt off? Maybe the windows are blacked out, or there is no mail in the box, or the front door doesn't have a handle. In cities like London, New York, and Paris, there is a high probability that you have walked past a fake building. These are essentially architectural shells designed to hide the industrial guts of a city from the public eye. In London, for example, There is a famous spot at 23 and 24 Leinster Gardens. From the street, it looks like two beautiful, high-end Victorian houses. But if you look closely, the windows are actually painted on, and there is nothing behind the front doors. These are dummy houses built in the 1860s to hide a massive vent for the London Underground. Back then, steam trains ran through the tunnels, and they needed a place to release the smoke and sulfur without ruining the neighborhood's aesthetic. In New York City, a plain, windowless concrete skyscraper at 33 Thomas Street towers over Manhattan. It looks like a villain's lair, but it is actually a high-security switching center for long-distance telephone lines. These buildings are designed to be invisible by being so boring or so perfectly blended that your brain just skips over them. This is known as stealth infrastructure. Whether it is a fake house hiding a subway vent or a cell phone tower disguised as a pine tree, the city is constantly lying to you to keep its messy parts hidden. It's a way of maintaining a sense of normalcy in a world that is becoming increasingly mechanical. Up until now, we have lived in cities that are passive. They sit there, we use them, and they eventually wear out. But we are currently entering the era of the sentient city, where the infrastructure around you is beginning to wake up. Through a massive network known as the Internet of Things, our buildings, roads, and even our trash cans are starting to talk to each other in a constant, invisible stream of data. Imagine a street that knows exactly when a car is approaching and dims or brightens its lights to save energy. Or consider a smart bridge embedded with thousands of tiny sensors that can feel a microscopic crack forming in its steel. Instead of waiting for a human inspector to find the problem, the bridge sends an alert to a repair crew before the danger even exists. This is predictive maintenance, and it is turning our cities from decaying concrete into proactive ecosystems that in cities like Singapore and Barcelona. This is already a reality. They use digital twins, which are exact virtual copies of the city that live in a computer. By running simulations on the digital twin, planners can predict how a new skyscraper will affect wind patterns or how a sudden rainstorm will impact the drainage systems blocks away. It allows a city to think before it acts, making urban life smoother and more efficient. However, a city that sees everything also raises questions about digital privacy. As our environment becomes more aware of our movements, the line between public safety and constant surveillance begins to blur. The future of our cities won't just be about how high we can build or how fast we can travel. It will be about how we balance the incredible benefits of a living city with our need to remain anonymous in the crowd.